So let me show you a few things about the for loop statement. This is one of the simple examples that we began with in the lecture slides. We have an unsigned integer called counter, which we are initializing in the for loop, and we're going to run this for 10 iterations. The counter variable is incremented by 1 over here in the third argument for the for loop, and we print out each value of counter as an unsigned integer over here. If you run this, get the numbers 1 through 10. And just to demo that you can do the same thing with the pre-increment operator, gets you the same output. And let me also show you that you can also define counter inside the for loop statement. And it works the same way. So a few more things. Instead of counting up by 1, we can also count up by any number you want, let's say 2. There you go, 1, 3, 5, 7, 9, because we are initializing counter to 1. If you just want the even numbers, initialize to 2, and there you go, 2, 4, 6, 8, and 10. You can see that you can use pretty much any expression over here for the increment expression. So let's count a little further. Let's say you want to count to 100 starting at 0, and you want to increment by 10. There you go. 0, 10, 20, 30, 40, 50, all the way up to 100. So play around with it, try it out. Oh, let me also show you the decrement version. So we start counter at 100, and we're going to count as long as we are greater than equal to 0. And I'm going to subtract 10 from the value of counter. So this is going to count down from 100. Oh. So the problem here was that counter is defined as an unsigned number. So after counter reaches 0, we subtract another 10 from that, and that creates the problem, because the result of that we expect to be a negative number, but that because counter is an unsigned integer, it's not a negative number, it is interpreted as a very large positive number. So I'm going to change that to an int, change that to a decimal number, just like that, and let's try that again. And there you go, 10, 90, 80, 70, 60, 50, 40, 30, 20, 10. And put an equal sign over here if you want to print out the 0 as well. And there you go. And some of the examples, or similar examples, with different counter variables that we saw on the slides. So let's say you want to start at 7, count up all the way to, let's say, as long as it's less than equal to, I think it was 77, and we're going to go by increments of 7. 7. There you go. So counter starts at 7, goes all the way up to 77, and we count up by 7 in every step. There you go, 7, 14, 21, 28, 35, all the way up to 77. And another one that we had over there was we initialize counter to 44. We want to keep going as long as this is greater than equal to 0, and I think we were counting down by 11. And there you go, 4, 44, 33, 22, 11, and 0, the last iteration. And I'm going to change this around a little bit. The one in which we added up all the even numbers between 0 and 100. So that was this code over here. We defined an unsigned integer over here called, I think we called it number, and initialized that to 2. And we keep counting until number is less than equal to 100, and number is incremented by 2. And over here we update the value of sum, and yeah, I think that's, and yeah, let's also print out what we're actually trying to find, the value of sum. So sum of all even numbers between 0 and 100 is dot 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 percentage d slash n, and then we print out the value of sum. And let's try that out. And there it goes. Sum of all even numbers between 0 and 100 is 2550. I believe that was the output value that we saw shown in the slides. Okay, and one other thing, I said that it's also possible to perform this operation over here, up here, together with the incrementing of the variable number, and yeah, and we can even let's go step by step, which leaves the for loop kind of empty, and which is fine. We just leave the semicolon over here, basically no operation. And there you go. Sum of all even numbers between 0 and 100 is 2550. Still the same output. And if I want to bring this even further in, I can even initialize the value of sum inside the for loop's initialization part. So let's try that again. Oh, did something wrong over here. Have a comma, yes. Okay, so yeah, actually you can't define number over here if you're gonna initialize both number and sum. So we're just going to initialize number and sum in the for loop. I'm going to define them outside the for loop, and that should work. There you go. Yeah, sum is 2550 as it should be. Finally, let me show you the example in which we compute the profit earned on an investment on a principal amount. So let me just put that code in here. So here's that code. I just put a block comment on what we were playing with before, the simple for loop. I added the math.h header file using the hash include preprocessor directive, of course, because I'm going to use the power function over here. I have the double precision floating point number principal, which is the amount that I'm investing. I have the rate 5%. 5% written as a decimal number is 0.05. I'm printing out the header that's going to appear on top of each column year and amount on deposit, and I have my control variable year, which is an unsigned integer, going from 1 to 10. I compute the amount that I've earned after year number of years, and I compute those using the same formula you saw on the slides: principal amount multiplied by 1 plus the rate to the power of number of years. And I print them out over here using this formatted output. I print out the year as a 4-digit unsigned number, and I print out the amount I'm computing as a 21-digit number with 2-digit precision, floating point number. Let me run this. There you go. I added an extra new line over here to make it look a little nicer, and you can see that all the numbers are right aligned. I want to show you one last thing. You'll notice something different over here. The amount double precision floating point number is being defined inside the for loop, and obviously this will happen again and again. I also want to show you something about this unsigned integer control variable year. Let me add one line of code at the end, or try to add this line of code at the end, outside the for loop. Okay, so let me try to print out the last value of floating point variable amount. You see something right away. Amount has a squiggly line over here, and it's not highlighted in blue. And you can see a warning message over here. Identifier amount is undefined. For some reason, the compiler does not recognize amount as a variable at this place. I've been using it right here and right here. And the reason for that is that I'm defining amount inside of a for loop. Now, when you define a variable inside a for loop like this, or actually a while loop or any other type of loop, that variable exists only inside the for loop. After you exit the for loop, the variable is kind of deleted from memory, does not exist anymore. It's nice because that lets us limit the amount of memory our program uses. It's kind of like deleting your variable after if you only need it for a short time for a specific task inside a loop. So if I try to compile this, I get an error like this. So put in other words, the scope of the double variable amount is only inside each iteration of the for loop. Actually, what's happening is that after each iteration, we are redefining amount. We are redefining the amount double variable over here. And this is not only true for amount, it's also true for the control variable year, which is being defined inside the for statement. Let me print out the variable of year and see the same thing again. Identify year is undefined because it has not been defined outside the for loop. It's defined inside the for loop. Let me change that. Let me define year outside the for loop, and let me print out its value over here. And you can see year already turned blue, which means it's being recognized as a variable at this point. Run it. No problem. And you can see the last value of year is 11 over here. Make that 4. And there you go. 11. And guess what? The same is true for amount. If I don't define amount in here, if I define it outside without initializing it, all of a sudden I can access amount down here again because it continues to exist even after the for loop. define these variables inside the for statement or even inside the body of the for loop, and they'll cease to exist as soon as you exit the for loop. And there you go. 1628.9, the last value, sorry, this is the 2, the last value that that amount took, 1628.9, 1628.9, the last value that it took when year was equal to 10. When year became equal to 11, we exited, the value of year stayed at 11, and the value of amount is the last value that we wrote to it.